Hi, my dear students. Welcome you all. Welcome to Unacademy. This is your BOOLEAN sir. As we are continuing our uh, digital Barfi series, we are continuing the next topics. And so we are planning the Boolean algebra we have completed. Now we'll continue the logic gates. चलिए आज का सेशन हम शुरू करेंगे. इसके पहले हमें बढ़िया से बढ़िया ऑफर आए आपके लिए. So in for GATE 2024 के लिए, you can have a look at now here. In GATE 2024, you can see. So here top 7 AIR 1 ranks from Unacademy students only. Now it's time for you can start your serious preparation with the Unacademy to achieve your dream goals. Right. So you can see now different branches. Electrical may be I, CSIT may, EC may, and CH and IN, PI, NM. All these different branches. The toppers from Unacademy only. Now it's time for you can start your serious preparation with the Unacademy to achieve your dream goals. So we are launching the new branches, new subjects we are launching. To enroll for it, you can use my referral code of BWRD. So there are new batches for 2025 के लिए and 2026 के लिए you can see now here. 26 के लिए नया बैचेस भी शुरू होने वाला. नवंबर 15 से शुरू हुआ and नवंबर 30 से हमने नेटवर्क शुरू होने वाला for 2026 2027 के लिए. Right, there are new batches you can see for 2027. And another biggest thing is the Unacademy GATE scholarship test. The test is going to conduct on November 25th, 4th at 11 a.m. It's time, so now you can start your serious preparation with this. You can achieve your dream goals. इसीलिए here you can get the laptop भी मिलेगा, smartphone भी मिलेगा, tablets, and so you can get the family vacation in 5-star accommodations. And and कम से कम आपको गेट फी का रिफंड भी मिलेगा. This is the least case आपको मिलेगा. You can enroll for this Unacademy scholarship test and you will have a बढ़िया से बढ़िया so here exciting rewards आपके लिए इंतजार कर रहा. Laptop, yes, tablets and smartphones. Do enroll for this Unacademy scholarship test immediately. Don't make any delay. The date is on November 24th at 11 a.m. And their list of books Unacademy GATE iconic subscription students can get. These are the list of books for electrical के लिए. All the books now here you can see now electromagnetic fields, network theory, measurements, and digital, machines, power systems, and power electronics, analog, signals and system, control system, maths, aptitude. All these books are delivered to your home address within 15 days of your subscription. Next, there is a list of books for EC के लिए. You can see now here EDCI, network theory I, electromagnetics, analog electronics, signals and system, control system, communication system, digital electronics, and engineering, maths and aptitude. सारा के सारा books आपको मिलेगा within 15 days of your subscription. And keep in mind, ये books केवल Unacademy iconic subscription के लिए की मिलेगा. ठीक है, चलो आज का सेशन हम शुरू करेगा. So without any delay, so here let's start our session. In the last class we have finished up to 100 problems. We have finished it now. Now let's continue the remaining problems. Now define the connectivity for the Boolean variables. They're given as something x star y. They given this operation as what? Tell me now here. X bar y bar plus xy. So can you tell me now what is this operation is? Nothing but what? Tell me now here. X NOR operation. This is nothing but what you tell me now here. X NOR operations. We can see now here X NOR gate का properties एक बार स्मरण करिए. Now which of the following will be true? They are asking. Now here if x NOR y which is equal to z, the property is what? Tell me now here. Then y x NOR z which is equal to x, and z x NOR x which is equal to y.
you can see now here y 𝐿0 will use what element? X 𝐿0 will use y. Next, this will be a 1. So that means what we can say now, all P, Q, R are valid, correct. Now, let the binary operator define as like this. Now you tell me what they given now. X hash slash y, which is given as what? Tell me now here, x bar plus y bar. So what is this operation? You tell me now. This is which we can say now xy whole bar. So that means this operation is what? Tell me now, NAND operation. Now what is this operation? NAND operation. This NAND operation can, so what it can do here, this NAND gate, it will obeys the commutative law, but it does not obeys the associative law. NAND gate, so के लिए क्या होगा? Tell me now here, commutative law. It will obeys commutative law, and it does not obeys. It will obeys the commutative law. It does not obeys associative law. So that means what we can say now here, this one first S1 is what I'll make commutative associative law. So that's why this is not correct. S2 is what I'll be now here, commutative law. This is correct. So only it will be S2 is true, S1 is wrong. Next, let x1, so this XR between 4 variable is 0. Now they are asking the which are the following must always true. Will be true always. Now, always true they are asking. So we need to give it some generalized manner. हमने देना पड़ेगा. If you have taken the scenario like this. We'll see here x1, x2, x3, x4. Now we can check this thing, this one by one operation. Option A kya hoga, you tell me. So when the XOR gate output is 1, you tell me, for in case of a even number of ones or odd number of ones. Odd number of ones ke liye output is 1. So the possible outputs we have taken this thing as, agar humne, so here inputs we have taken it as all zeros we have taken. So in this case, what happens, you tell me now here. अगर ऐसा हमने ले लिया तो so the उसी का scenario क्या होगा? Now if you have taken this thing here, so this product will be 0, and here there is another possibility when we have taken all ones we have taken. Now here in this case, this case first condition must, when all ones, this case not satisfying. Okay. Next, and we'll take some counter for each one. We'll try to verify this thing. and the sum equal to 0. This is also not possible. Next, this is 0 means x1, x3. If you have taken this condition, okay, if we have taken this thing here all ones, now this is also not satisfied. Okay. The only possibility is what we consider this one. So this is what they given now, x1 bar XOR with x3 bar, and which will be equal to x2 bar XOR with what element of here, x4 bar. This is what we can say now, x1 XNOR with x3, which is equal to what element of x2 XNOR with what element of here, x4. Now this condition we need to verify it. Now कोई prompter है क्या इसमें? Any example so that this cannot satisfy. So कुछ inputs लेके check करो. Whatever the inputs we have taken, this can be satisfied. If we have taken this now, this case, this will satisfy now. It's satisfy or not. Next, for this, we have taken this now here. In this case, also satisfy. We have taken 1 0 0 1 satisfy. So 0, yes, now here 0 1 1. In this case 1 1, yes, satisfy. You can check now all different input. This condition is हमेशा satisfy करेगा. Next one. I don't get the following is not correct. So tell me now which is not correct. P XOR Q bar, which is equal to P XOR only. So this is correct only. Option B, P bar XOR with Q, which is equal to what element of P XOR Q. Second option also correct. Third option is what element of P bar XOR with Q bar. So then this is what element of here, and it will use as P XOR Q. So this third one is not correct. Okay, now you can see now D. So here D, if we can verify P XOR with P bar XOR with Q. So you tell me what I'll get now here. 1 XOR with Q. So it will come to be a what element of here, Q bar. P XOR with P bar XOR with Q. So this is what element of different input के लिए 0 है. 0 XOR with Q. So here it will be a Q bar. So this is also correct only. D is also correct. So then only C is wrong answer. Identify the logic function performed by the circuit. Yes. Now this is a Barfi जैसा लग रहा कि नहीं? And you can see now here. So here this is x plus y bar, x plus y whole bar, x plus y whole bar. Here this is x plus y bar, again whole bar. This is y plus x plus y bar, again whole bar. Now finally this f will come to be a x plus y bar say whole bar plus y plus x plus y bar, again whole bar. Yeah, simplify this thing. What will come here? X plus y bar into y plus x plus y bar. Now this is f is equal to what will come here? X plus, this is x bar into y bar, y plus x bar into y bar. Now you can simplify this thing here. This is x plus y bar. This is what element here? Y plus x bar. Now if we multiply, we can apply that T2 clear. So I'm calling this is 1, 2, this is 3, this is 4. Is F, it should come to be a. So tell me now what we'll get now here. X, Y plus 1, 4, 2, 3, x bar, y bar. This is nothing but what tell me now here? X naught. Next, the logic expression for the output of the circuit shown in the figure below is, tell me now. So here this is AB bar C, and this is what element of AB bar into C whole bar, and this is CD bar. Now you tell me now the F, what will come? The F will be what we can say now here, AB bar into C whole bar into CD bar whole bar. So you tell me now what will come? AB bar into C plus what element of CD. So then F is equal to what I'll get? A bar plus B bar into C plus CD. So this means what the option you see? A bar C plus B bar C plus CD. So what's the option you see? Option A. Next, which of the following operations is commutative but not associative? Yes. Now, the NAND gate, NAND and NOR. So, these will satisfy commutative but not satisfy associative. Not associative distance. Next one. So the following expression is not equal to x bar. Not equal to. So here option A, NAND gate given x into x bar, which is x bar only. Next, x plus x bar, which is what else now? That is also NAND only. You can see here x into 1 whole bar, that is x bar only. Option D, x plus 1 whole bar. 1 plus anything is 1. 1 whole bar is what will be now 0. This is not a not operation. Next. F1, F2, now this is F value given, we should find F3, we should find NAND gate, careful, NAND gate. So here the one tarika is what tell me now, converting this into a under gate. That is one tarika. After that, otherwise directly you can do. What we can do here, you can see, tell me now here, if you want to convert into AND OR logic. So AND OR logic, what we can do here, this is the bubble. This NAND gate is equal to bubble to OR gate. Sir, no. Now, this bubble, I can replace this thing as what, tell me now here. Next, here we have a NOT gate. Now I am replacing this thing as a NAND gate as a bubbled OR gate. Okay. Now what I can do here, so this bubble I am cancelling. This bubble I am cancelling. Now it will behave like what you see this thing here. Now this part, it should be equal to simply what I can say now here. AND gate. And this is a NOT gate. And thereafter we have a OR gate. This is a functioning terminal. This is F1, F2, this is F3, and this is F. Okay. Now simply, so if you remember, two level AND OR logic is nothing but NAND logic. हमने देखा a property, isn't it? Remembered? AND OR logic is nothing but NAND is nothing but what tell me? AND OR only. So look at now here. F1, F2 we have given. So now this is like an AND gate only. So what the AND gate now here? It will use what I mean a common minterms will come. So F1, F2 में कोई common है क्या? There is nothing common. So nothing will come. Empty set. Nothing will come. Okay. Next. में कुछ भी नहीं है इधर. Next, output F में क्या चाहिए? You tell me now here. We need 1, 4, 5 चाहिए. That means here, this is like a buffer. Okay, buffer you can simply connect it better. Okay, now you tell me now here. So this will be nothing is there. So must be F3 must be contained 1, 4, 5. Then only output में वो A होगा ना. So option A. Next the F. Which are the following statement is true. Now here we have this X. Here what will come? You tell me now here. X, Y bar, whole bar. And this is what tell me now here? YZ. Now you tell me now what is this F equal to what tell me now here? X, Y bar, whole bar into Z bar. So whole में होगा. Is YZ. Only F will becomes as what tell me now here? X, Y bar plus, yes, this is YZ bar. This means it will come to be X, Y bar plus Y bar plus Z bar. We have taken y bar we have taken common, then it is 1 plus x plus what tell me now here, z bar. F is equal to what we can say now here, y bar plus z bar. Now you can see this is independent of what tell me now here, x may independent hoga, it has only, it depends upon only y and z only. What is the Boolean expression for the output of a combinational circuit? You can tell me now here, this is P plus Q whole bar. So this is Q plus R whole bar. Here also same thing, na? Here also P plus Q whole bar. This is Q plus R whole bar, same thing. Now you tell me now what I'll get now here. This is P plus Q whole bar into, sorry, plus Q plus R whole bar whole bar. इसमें क्या आएगा? That is P plus Q into what tell me now here, Q plus R मिलेगा. Exactly same thing here also. P plus Q into Q plus R मिला. If we apply the T1, we say this is 1, 2, this is 3, this is 4. T1 if we apply. So tell me now what we'll get. 1, 3, 2, 4. So that is Q plus, what tell me, 1, 3, 2, 4. That is PR. Here also same thing now here. Q plus PR. We come here. Q plus PR plus what tell me now here, Q plus PR का whole bar. Get na? So finally what we can get, you tell me. So same thing only na, both are same, so we can say Q plus PR whole bar. So कौन सा option tell me? Option D. Circuit is not equivalent to XNOR gate. So here, so this XR not, so this is the XR gate only now. Here we have, this is 2 bubbles. XR gate is nothing but what tell me, this is XR, again not XNOR only. 1 bubble XR will use XNOR, yes. Here, if I say this is A and this is B, so here will come it as AB bar. Here will come it as A plus B bar. Here again AB bar whole bar. That means what tell me now here, A bar plus B here. Next here, this is what tell me now here, A bar plus B, and this is A plus B whole bar. Then finally F will come. And what will the F will come, you tell me now here. This is A bar plus B into what tell me now here, A plus B bar ka whole bar, not a gate now. So here tell me now F will come to be. We can apply T2. So that means what I can say now, A bar B bar plus AB whole bar. So this is a XNOR ka complement na here. XNOR ka complement, it is XR banega. we need हमको x0 चाहिए. So this is not x0, this is xr. So this option B. Next, which one of the following expression does not represent exclusive NOR of x and y? X NOR, which is, so you tell me now here. Yeah, so this is, what is the x NOR y, which is equal to what? Tell me now here, x bar y bar plus what? Tell me now xy. Next, x xr y bar. Yes, this is nothing but what? Tell me x nor y only. X bar xr y. And what is this thing here? X nor y. Next, this is x bar xr y bar, which is equal to what? Tell me. This is nothing but what? Two bubbles means xr only. So this is xr. So this is not. Next, consider 3 4-variable functions of SOP f1, f2, f3 given. Now we need to get what? Tell me now here, output. F we should get now here. First f1, f2 they given it as an AND gate. AND gate में क्या आएगा? Common terms मिलेगा. Common terms here, this is 2 is common. Next, what else common? You tell me now. 6 is common. And what else now here? 14 is common. So this common terms हमको मिलेगा. That means here 2, 8, 14 मिलेगा. And F3 में क्या है? You see this thing 2, 7, 11, 14. And अभी इसमें हमको क्या मिलेगा? XR टाइम कॉमन ओन कम. तो कोई कॉमन है क्या इसमें? Common terms won't come and outside term also won't come. Only A and only B. Only A means इसमें कोई common terms है क्या? Tell me. Common terms 2 है, so ये 2 नहीं आएगा. 14 है, 14 भी नहीं आएगा. So finally F में क्या होगा? You tell me. That is 7, 8, 11 होगा. So कौन सा option? A. Recollect the Venn diagram. Venn diagram of a XR gate is what you see this thing here. Now if we have say this is A and B, so XR gate में क्या मिलेगा? You see this thing here इसमें. So then this part will come. Only A. And only B. A, sir, this is the Venn diagram now. Tell me. Yes, common things won't come. Outside also won't come. Hmm? Okay, next one. Yeah, take the next one. Here, this problem. Yeah, this problem also we did so many times in class. So this is A comma B comma C, which is given as what element of here? AB plus BC plus AC given. Now let us find the minterms of this expression first of all. And what will be the minterms of this MU? Tell me. This is nothing but full adder carry. So the minterms are, remember this minterms, that is 3, 5, 6, 7. Remember this thing so many times. Now 3, 5, 6, 7 we got it. Fine. Now you see what we need to find here. Look at here. They given some function that is f m of, this is given m of a comma b comma c. Okay. Next, m of a comma b comma c bar comma c. Right. So then it will come to be what you see. I'm calling this as a x. This I'm calling it as y. This I'm calling it as z. So you tell me now, what is this x? You tell me. So this is x is equal to what? Tell me now here. M of a comma b comma c ka whole bar. You tell me now, what is this thing here? Now this minterms are 3, 5, 6, 7. So then x means other than this now. So what will be complement means? What? Tell me now. 0 comma 1 comma yes 2 comma 4. Next x. And whatever the y minterms, you tell me. M of a comma b comma c bar. So that is what you tell me now here. AB plus BC bar plus AC bar. Now you tell me the minterms here. That is what we can say now here. 1, 1, 0, 1, 1, 1, 0, 1, 0. Yes. 1, 0. Next 1, 0, 0, 1, 1, 0. So you tell me now minterms here. M of a comma b comma c bar, which could be given as what we can say this is. Now here we have a 2, 2i, next 3, 9, 4, 4 is there, 5, 9, so 6, 7. Check this thing all of you. So we got this each minterms we got now here. Now what we need to do here, this required thing we need to calculate. So you tell me now here. They given m of what? Tell me now here. M of a comma b comma c. This we have taken as what? Tell me now. X we have taken. This we have taken as x. This as y. This as z. And that they given as what? Tell me now. This is the form they given. That is what? Tell me now. AB plus AB means here. In place of a, we have a x is there. So that is xy plus yz plus what? Tell me now here. Xz. X into y. That means if we multiply the minterms of x and y. X and y minterms if we multiply, see common things only will come now. What will come here? Common क्या है? 2i 4i. इसमें दोनों में 2, 4i. Next. yz में क्या है? Tell me. Y and z. Okay, z we did see na. So let us find z minterms also. Z means what? Tell me now. Keval C na. Keval C. So this means what are the minterms you can see now here. So here 0 0 0 1 1 0 1 1. So this is 1 1 1 1. So the minterms are what you tell me. That is 1, 3, 5, 7. Y into Z में so common क्या है? 7 common. So here इसमें 7 आया. Plus Z into X में Z into X. What will come? 1 will come. Common is 1. So that means finally what are the minterms will come? You see 1 2 7. ये 1 2 4 7 हमको बड़ी बात है ना. We know very well this thing. This is nothing but what will be 3 input XOR gate. Option B. Next one. A universal gate can implement any Boolean functions by connecting sufficient number of them appropriately. 3 gates are shown. Which of the following statement is true? Universal gate. So here this is called functionally complete. Which is the functionally complete here? Yes. Now here this C expression is functionally complete. So option C. Functionally complete. Next. A Boolean function is given as like this, assuming complements of x and y are not available. Minimum cost solution for realizing f using only 2 input NOR gates and 2 input OR gates is. In these cases, you see this thing, all these cases output is 0. In this case only output is 1, in this case 0. So I can write this as f of a comma b if we consider. That is what tell me. Instead of writing SOP form, POS form I'm writing. So that is what tell me now here. A plus a bar plus b I can write now. POS form. They're asking to implement this only 2 input NOR gate and 2 input OR gates. Yes, हो जाएगा. Have taken here, it is one NOR gate we have taken, and this is A, and here I am taking one OR gate. Okay, so that means how many gates we have? 2 gates are required. Each gate will take the 1 unit, so that means how much the cost it is? 2 units. Next, the complete set of only those gates designed as a universal. Only universal gates are what I'll be known NAND gate, NOR gate. If the multiplexer is there, multiplexer also comes under universal. Next one. All the logic gates shown in the figure have a propagation delay of 20 nanoseconds. A, C 0, B 0 until t is equal to 0. At t is equal to 0, all the inputs flip, mean changes, and remain in that state for t greater than 0. The output Z is equal to what? For a duration of, right. This type of problems are very important, very good problems. Okay. So look at now here what they give. So here this line is at t is equal to 0. Until t is equal to 0, AC values are what tell me now? 0. B value 1. Okay. Now here this input is A, and this input I am calling it as something here. This is Z. This input I am calling it as, let us say, F1. This one. And this I am calling it as F2. This is C. Now you can see now here. First we can see how this A and B you need to see here. A and B we need to draw it. So A value. So from t is equal to 1 onwards, A value 1. So this is 0. Now onwards, at t is equal to here onwards, this is 1. Now tell me. And this is A. Next, F1. What about this F1 is a B. First we'll draw B. B is what tell me now here. This is t is equal to 0 onwards, B value 0. And this is B. Now let's get the F1. F1 is what tell me complement of B, but they given that it has some delay now here. Here t value how much here? 0. Has a delay. Each gate will have a delay of 20 nanoseconds. Because of the delay, so this output will becomes what you tell me now here. It will toggles by how much? The whatever the action will be takes place, that action will take place after 20 nanoseconds. This is F1. Now at this location, time is how much here? 20 nanoseconds. Now F2 is what tell me now? A into F1. So if I don't have any delay, so see the scenario now here. Here onwards, at 20 onwards, both inputs are 1, means what tell me output will becomes 1. But because of the delay, see what happened now here. Now, so here if I don't have delay, so then up to 20 onwards, it should becomes 1 like this. But delay is there, now how much the delay is at 20. Because of the delay, see what happens now here, this will be further. So 40 onwards is 1 now. So then F2 will becomes what you tell me now here, 40 onwards, which is 1. Okay, next C. What about a C? You tell me now. C input we didn't take in. A C input is what? Tell me now here. T is equal to t greater than 0 onwards. It is 1. So C value 1. Initially 0. Now the C value becoming 1. So this is C. Now this XOR gate delay. XOR gate is given. Now you see at this location, this is 0, this is 40. When the output of XOR gate is 1 for different inputs, you see from here to 0 to 40, this is 0, and here to here also 0 to 40 also 1. So then output will becomes, if I don't have any delay, between 0 to 40, output is 1, thereafter it is 0. But because of the delay, how much the delay is at 20, so final output क्या होगा, you tell me? Final output क्या होगा? It will be final output Z. So this is 1. It will be from 20 onwards, 20 to 60. 20 to 60, this output is 1. Here this is 20 nanoseconds. This is 60 nanoseconds. So this duration output is 1. Now what they are asking in the problem, you see, this duration they are asking. Now how much duration? This is 1. How much duration, which is 1, you tell me? 40 nanoseconds. Completed. Next. Consider the logic circuit with the inputs. Test signal is given as like this. All the gates in the figure shown have identical non-zero delays. The test signal, which was logic low and switched to logic high and maintained at logic high. The output is, now here this is the test signal is input A. Let us say this Y is my output. Gates they given now. What they given? All the gates in the figure shown have identical non-zero delay. So let us say this will have a delay of 1 nanoseconds. Each one will have a delay of 1 nanoseconds. This also will have a delay of 1 nanoseconds. Tell me now here what I will get. So here first test signal they give it as logic 0 and switch it to logic 1. So initially, if I call this is B, this is C, this is D, and this is A only. Now initially they are saying it as, so A test signal which is logic 0, it is switched to logic 1. Right, this is A. Next, what about the B? You tell me now. Complement, because of the delay, so then it will come like this now. How much the delay it is in? This is 1 nanoseconds. Next, C. So this is another complement of B. This is again delayed now here. So then it will come to be a what you can see. This is C. Now here this is 2 nanoseconds. Next again complement. So then it will becomes what you tell me. And this is 3 nanoseconds. Now here this is a NAND gate. When the output of NAND gate is 1, if any one of the input is 0, then it is 1. Now you see this thing here. Initially this is 0, here this is here. Now this final output kya hoga? You see this thing here. Initially output 1 banega. Initially, thereafter will becomes 0. Now it also has some delay of 1 nanosecond. So that's why it will be like this. At 1 nanosecond ke baad it will become 0. And from where to where now here? 0 to 3. So means 1 to 4 tak 0 banega. 1 to 4 tak 0. Thereafter it will becomes 1 banega. So this is the output Y. At this location, this is 1 nanosecond and this is 4 nanoseconds. You can tell me now here the pulse. So initially pulse from high to low. Yeah, you can see now high to low, high to low, high to low to low to high. Yes, option D. Right. Now you tell me now this thing. They given the input signal as given as like this. This is the input signal. At t is equal to t naught, this we have. Look at now here, this is the input now Vi. So what I will get, you tell me now here. So this is Vi bar complement now. So NOR gate. And this is what will be XOR gate. So how much the delay of this gate is given? This delay they given as 10 nanoseconds. Okay, G1 delay 10, G2 delay is 20. Now see this thing here. This is the scenario. Initially the input is like this. T naught onwards 1. Before it is 0. Now you tell me now. So this will be flipped now. Vi bar. Vi bar kya hoga? You tell me. Complement of this input. So complement means, so this is 0 will becomes 1. But लेकिन इसका कुछ time भी लगेगा because of the delay से. Now this is what we can say now here, Vi bar. Then what is this, you tell me? Vi bar. So this is T naught. T naught plus kuch time. How much the time is it? 10 nanoseconds. Next. This input and this Vi direct input are given as XOR gate. When the output of XOR gate is 1 for unequal inputs. So up to here, this is 1 and this is 0. So output is 1. But because of the delay ka wajah se, so you tell me now what happens. How much the delay is 20. So T naught plus 20 hoga. So in this interval only output is 1. XOR gate na. No. In this interval output is 0. So here is 1, here it is 0, here it is again 1. So means how should be now at this location will becomes T naught plus 20. T naught plus 20 means more than 10 na. This is 1 up to where you tell me T naught plus 20. इसके बाद T naught plus 30 तक it is 0. T naught plus 30. Thereafter again it is 1. So at this location this time is T naught. And this is what we can say, tell me now, T naught plus 10. And this time is what tell me now, T naught plus 20. Okay, this is what tell me now, T naught plus 30. Now, so this is T naught. They given T1, they given this as a T2, they given this as a T3. So you can check the options now. T naught, T1, T2, T3. कौन सा option होगा you see? Option B ना? Check करो. Yes, option B. Next one. Which one of the following is equivalent to and or realizations? Which is equal to under? NAND is equal to under. हमने बहुत बार देखा ना? NAND. Which is equal to what element of here and next. This is also delay problem. You can see now here. Here also we should draw one by one output. We need to draw it. Input given as like this. A given, B given. So they ask him to find what should be the output. You can tell me now here what we can do this one. Now this is what I will know A plus B bar. Next this is A plus B. Again this is B. So will come to be what tell me now A plus B banega. That is nothing but what tell me now here R gate. Output of R gate हमने देखना पड़ेगा. So when the output of R gate is 1, when any one of the input is 1, output 1 banega. Now you see this thing here. Now this value, this is 1 यहाँ तक. Yes, now यहाँ तक output is 1 होगा. Now in this interval only 0 banega. Remaining all the cases means what we can say now here output which time. This time is 1 and 5 milliseconds 0. Thereafter again it is 1. Kitna time is 1 you tell me now? This much. यहाँ से यहाँ तक 15. 15 it is 1. Again 10 it is 5 it is 5 it is 0 and 15 it is 1. 15 it is 1 and 5 it is 0. Yes. Like this we have now, you can see. कौन सा option होगा tell me now? Yes, might be this also periodic, maybe 15 होगा this thing. This is 15 milliseconds and this part is there now. This is a 5 milliseconds. And again this is 15 milliseconds and this part is a 5 milliseconds. So कौन सा option tell me? Option B. Okay. Next, this also the delay problem only tell me. And A plus B whole bar. NAND gate is given, so it should be equal to what tell me now here? AB whole bar. When the output of NAND is 1, delays are neglected here. If any one of the input is 0, output 1 banega. So here this is what tell me now 0 is there, so output 1 banega. यहाँ से यहाँ तक output 0 means so it will be 1 होगा ना इधर. Here both are 1, so output 0 बनेगा. Next here 1 output 1 बनेगा, here 0 बनेगा. You can check this option now here. Option D clearly you can say. Next one. So they given this as the duty cycle they ask him to find. Check this duty cycle now here. Input is given, output is given. 0.4 V to 1.5 they given this voltages. Input output is given. Tell me that duty cycle means on time by. So this is how much the on time you can see this value. Duty cycle. So D if I say, which is nothing but what tell me now T on by T total. T total means from यहाँ कहाँ से कहाँ तक here tell me now up to T2 तक we should take. Here up to here. Next. So you see this thing here. This is T1, T2 values given. T1, T2 values not mentioned. Na? So let us get the relation between them. How we can get the relations you see? Try करो this one. on on time is how much? Off time is how much? From here to here, this is what will be output is 1. This time is T1. Next, T2 given. So this time is what will be now here. This time, this is the off time now. This duration, which is what will be off time. This is nothing but what will be T2 minus T1. This is nothing but what will be now T2 minus T1 now. You can see now T2 minus T1 value. So what we can do here, if I say this coefficient, this coordinates of this point is what we can say now here, T1 comma 1.7, and these coordinates are what will be now here, T2 comma 2.2. So yeah, this is a straight line now. Straight line. This is a nothing but straight line. So we can find the straight line. So these coordinates are what will be now here, 0 comma and 4. So then this straight line slope is same now. Straight line slope is same. So means what we can write, you tell me. Same slope must be there. 1.7 minus 0.4 by, so this is T1 minus 0. That is equal to what we can say here, 2.2 minus 1.7 by, so this is T2 minus T1. So this is the T2 minus 0. No, we'll find this thing. This is 0.4. Is what will be of T2 minus 0. Check this thing, all of you. So this is T on time is T1. This total time is on plus off is T1 plus T2, that is T2 now here, this one. Now we can get the relation here, 0.7, which will come to be 1.3 now, 1.3 by T1, which is equal to what will be now here, 1.8 by T2. We need T1 by T2. So that is T1 by T2, which will be equal to, that is 1.3 by 1.8. The duty cycle D, which is equal to 13 by 80. How much is value of 13 by 18? 72.2. So option C. Right. So we have finished this 125 problems. हमने complete किया. That's for this session, and we'll meet in the next sessions. Okay then. See you. Bye bye. Take care.